Okay. I'm going to graph this function. Okay. Now, people pretty much know how to graph polynomials. I see people graphing polynomials. I see people trying to make a cubic polynomial out of this. We'll talk about why that is. Okay, well, because there are only two values of x, it makes this 0. Okay. We can't go through the x-axis 3 times. And that's something to kind of keep in mind. But anyhow, okay, let's say we have f of x equals x minus 5 times x plus. And well, we know that f of x is 0, if x is 5 or -7, right? So we don't need to use the quadratic formula to find the zeros. So now I can start graphing. I can put -7 here. -7, 0, and I can put 0, 5 about here. Those are the only possible values. If x isn't -5, this isn't 0. I'm sorry, if x isn't 5, this isn't 0, right? If x equals -7, isn't -7, this isn't 0. Which means that for any values except 5 and -7, you're going to get two numbers that aren't 0, and two numbers that aren't 0 can't give you 0. Got a question, so get that. Well, come on, stop. Okay, somebody pointed out that I had the coordinates of this result, which I did. So obviously 5, 0, not 0, 5. Okay. Anyhow, this is what we know. Okay, well, we can find the y-intercept. And we plug in 0, we get -35. Pretty obvious. So now we know that we have -35, and I think I did that correctly. Okay. So at this point, you might be tempted to kind of go like this. But let's do the end behavior. Okay. X is a large positive number, then both of these are large positive numbers. 1 billion minus 5 and 1 billion plus 7 are about the same size, right? So you're gonna get a really big positive number because 1 billion times 1 billion. Okay, what's that? Well, that's 10 to the 18th. Okay, which is trillion, quintillion, if you like. But okay. Anyhow. It's going to be a very large positive number. The y is a huge positive number, so as x goes to infinity, y goes to infinity really fast. And that goes up like that. I kind of abbreviated it and wrote it fast, but x minus 5 and x plus 7 both be large negative numbers. Big old negative numbers, right? You multiply two negative numbers, you get a positive. You multiply two big numbers, you get a huge number. You want to understand that. So that means you're going to go up really fast over here. So you come down through here, you come down through here, and back up here. There's one more thing you know about this, that this graph is a parabola. So it's a quadratic. That implies that you have a parabola. And a parabola has an axis of symmetry that cuts the thing in half, and what happens in this half is just a mirror image of what happens in this half. Since that's so, the axis of symmetry has to split the distance between these 2 points. It has to be halfway between this point and this point. Well, the number that's halfway between negative 7, I didn't put the negative on that, negative 7 and 5 is 1. That's what x equals negative 1. When x equals negative 1, what's the value of f of x? It's negative 6 times 6, which is negative 36. So that I'm out of room here, so he's more bored. So I'm just going to write this in kind of abbreviated form. We'll discuss it a little further when we do this. Okay? But the vertex is at x equals negative 1. So to find the y coordinate of the graph on the line x equals negative 1, we plug in negative 1 and we get negative 36. And there's your vertex. So your vertex is here where x equals negative 1 and y equals negative 36. Now we've got 3 points on the graph and a fourth one here. We know the vertex is going to be the extreme point for the parabola. It's either the low point if the parabola opens upward or the high point if the parabola opens downward. So now we can apply all of our conditions. There's our graph. Okay. It wasn't necessary to expand this expression, although we could have. We can expand this expression and use the techniques that we're going to use with this. So let's do this, because more generally, this is more likely to be the case than this. In other words, here, your quadratic function is factored into 2 linear factors. This one ain't going to factor. Okay. Also not going to have 0. And now, we'll try to walk through the board. But I've got the board back here. Okay, so now let's take y. Equals x squared minus 2x plus y naught 17. Okay. Zeros Okay, using a quadratic formula, everybody knows how to do that. A lot of you did, even on the first part, right? And that would have been okay. Well, that's going to be 4, that's going to be negative 68. Oh, look at that. I didn't intend to have a perfect square there, but that's okay. Let's use that. Okay. Now, what's the square root of negative 64? Well, it's not a real number. Okay. Not real, so there are no x-intercepts. However, I'm going to complete this. Because this is coming up next week. Okay, well, negative 64 is negative 1 times 64. I'm ahead of myself. 64 root. Okay. That's 2 plus or minus I times the square root of 64 divided by 2. And you should be familiar with I from back in your algebra courses. Okay, but if not, I is the square root of negative 1. It's not a real number. Imaginary number, I stands for imaginary. That's 2 plus or minus 8i divided by 2. Okay. Of course, that's 1 plus or minus 4i. Well, that's not as helpful as you might hope because, again, there are no points on the x-axis. It's not a real number. But one thing you can say halfway between 1 plus 4i and 1 minus 4i is 1. Whatever 4i is. Okay. So, you know what the axis of symmetry is. It's x equals 1. So no zeros, axis of symmetry is x equals 1. Okay, well, let's see what else we can determine. The y-intercept is all right, it's 0, f of 0. This is a function f of x. Meaning just, x is 0, so we plug in 0 here to find the y coordinate, which is at 0, 17. Okay, so here we're going to have 0, 17. The vertex is on the axis of symmetry. Which occurs when x equals 1. So say it's at the point 1, f of 1, meaning just the x coordinate is 1, so it's got to be on this dotted line. And f of 1 is just what we get when we plug in 1. When you plug in 1, you get 16. So we have the point 017, and then here we have the point 1. I haven't done that very accurately, but we still get the idea. Okay. Another way to look at the end behavior, it's dominated by x squared, the highest power term. Because when x gets really big, x squared gets humongous. Negative 2x just stays big. Okay? If you do a big and a humongous, humongous wins. So when x goes to infinity, x squared approaches infinity really fast. When x goes to negative infinity, x squared goes to infinity again, because when you square a negative number, it's going to be positive. So the end behavior is that it goes up really fast here, it goes up really fast here. So we can now draw the graph. It's got to come down really fast, go through here, turn around, and go up really fast. There's our parabola. Okay. So let me give you another one to work on, because that's really what you got to know for the homework. Okay. That's your process. That's how you graph a quadratic function. There's a little more. You'll see some more in your open math assignment. But if you know this, you'll understand everything you read. Okay? Assuming you're a good reader. Okay, so you see you graph a quadratic function. Find the zeros, find the axis of symmetry, find the vertex, find the y-intercept, find the end behavior. Note that the graph is a parabola which is symmetric about the axis of symmetry. Find the zeros. If you know the factors, then you know where the zeros are, and your axis of symmetry is halfway between the zeros. If necessary, you can use a quadratic formula. Even if you have the factors, you can multiply them out, get the quadratic, do all that. Okay? And the quadratic formula tells you where the axis of symmetry is. It's halfway between the zeros, which occurs, well, halfway between negative b plus this and negative b minus this is negative b, follows the axis of symmetry is at negative b over 2a. So the formula for the axis of symmetry is sitting right there inside the quadratic formula. Just ignore the square root, and you've got the equation of the axis of symmetry. Okay, so find the axis of symmetry. That's easy. You can remember to do it correctly. And if you remember why, you find the vertex. It's the graph point on the axis of symmetry. You find the y-intercept, that's a point on the y-axis where x equals 0. Find the end behavior, and then your graph will be a parabola. It'll be symmetric about the axis of symmetry. So now try it. Y equals x squared minus 2x plus 2x minus 15. Okay, here's your function. Now, actually, this thing factors into y plus 5 and y minus 3. Okay, so sounds inconvenient, but I expect everybody went with the quadratic formula because that's what we did. And that's what you usually have to do anyway. So anyhow, negative 5, 0 plus 3, 0. So by factoring or by the quadratic formula, you get these zeros. I'm not going to go through that. People know how to use the quadratic formula, and hopefully you know how to factor. Okay. Again, you can find the negative b over 2a right there smiling at you in your quadratic formula. You get negative 1. Text happens that x equals negative 1 on the axis of symmetry. So y equals okay, you get this. That's going to be negative 2, negative 15, negative 16, but you have 1, negative 17, you have 1, you got 6. Negative 16. So at that point, you've got pretty much everything you need. I'm not going to write out the details at the end of the paper. You should think about that. So you have negative 5, 0. And 3, 0. You got the axis symmetry, it actually equals negative 1. Well, the y-intercept, I didn't do y-intercept. And explicit about it. I've written 0 squared plus 2 times 0 minus 15. And that, of course, I give you minus 15. These two terms will always be 0 on the y-axis. But you'll left over is your intercept. So we've got 0, negative 15. And 1, negative 16. Vertex is x equals 1, where y equals negative 16. That puts the vertex. Here. So, gotta go through these 2 points and these points. The end behavior you can verify above rapidly, just as in the previous example. So there's no correct. Okay. That's all there is to it, but of course you've got to practice that to get used to it. And you're going to do much better if you understand why these things work instead of just memorizing steps. Now, first, you're going to follow the steps. Remember also, you're not going to learn it by always having a list of these steps in front of you and examples in front of you. Okay? Now, maybe when you go through the homework, you need to do that. But remember my advice, go back and redo the homework without looking, or at least do selected problems without looking to make sure you know how to do these. Okay? Do them without reference to anything. Do them by knowing what you're doing. Okay? Because that's how you perform well on the test. Okay, to graph polynomials, three things. You find the zeros, you find the y-intercept, you find the end behavior, and then you make your sketch. Okay? Now, you also need to take into account multiplicity. Now, the first example I gave you, it's not going to involve multiplicities. The second will. Okay. So, graph this polynomial with your numbers. Then graph this, where x minus a is squared and x minus c is cubed. And let me change that. That's going to be a little neater. Draw to cube the x plus b. Okay, let's graph this first one. Y equals x minus 5, x plus 9, times x minus 12. Okay, zeros. And x equals 5, negative 9, and 12. Because if one of these is 0, you get 0. And if any of these, if all these are non-zero, you don't get 0. So we know by one that we have zeros at this point. Yeah. This point. And negative 9. Okay. Immediately, we got 3 points on the graph. Now, y-intercept. When x equals 0. If you look at what I wrote in the board, down here, if you review the video, whatever, you see what you need to do, and of course, open math is going to tell you pretty much the same thing. Y-intercept occurs when x equals 0. Y equals 0 minus 5, and 0 plus 9, and 0 minus 12. Well, 5 times 12 is 60, multiply that by 9, you get 540. And it's positive. So here we have 540. I'll just put it here. I don't want to put it too high because the graph might have to go above this point to come back down. Probably will on one side or the other. But in any case, we have a point. Zero, negative 40. Plus 1. Okay. So the end behavior. If X is a big positive number, then all these are big positive numbers. You multiply three big positive numbers, you get a huge positive number. Which means as X gets the positive side go up like this. If X is a big negative, and all three of these are negative, you multiply three negatives, you get a negative. You multiply three big numbers, you get a huge number. So you get a huge negative number. It goes down like this. And now it's easy to draw the graph. There are no multiplicities to take into account like there are here. The graph comes up, down here. Looks like this. Very straightforward cubic graph. Okay? Now, if the x minus 5 is squared, and the x plus 9 is cubed, we still have the x minus 12. What's that do? We got a 0 at negative 5, which is multiplicity 2. At 9, plus 5, sorry. At negative 9, multiplicity 3. At 12, multiplicity just 1. So the graph looks a whole lot like the other one so far. We have negative 9, 0. We have 5, 0. And 12, 0. The y-intercept is this. Okay. I didn't actually substitute 0 in the expression explicitly, but that's what it comes out, because if x is 0, you're going to get negative 5 squared. If x is 0 here, you're going to get 9 cubed. And if this x is 0, you're going to get negative 12. Now let's see, 9 squared times 5 is 405. 405 times 540. Do that quick in your mouth. Okay. Now let's see. 400 times 540 is going to be 200 and 400. 216,000. Okay. And then you got 4 more of those. It'll be about 218,000. Okay, about 220,000. Now, the other thing we got to worry about is you got 2 negatives here, right? You can square a negative. Well, you square a negative, you get a positive, right? This is positive, but then you're multiplying it by negative. So it's going to be like negative. It's going to be about negative. Negative 225. If I did my yeah, but okay. Your end behavior. If x is a huge positive number, all these are positive, right? So you're going to get a really, really, really huge positive number. It means after x gets past 12, this thing goes up very fast. Okay. Now, got to be careful. If x is a big negative number, then each of these quantities before it's squared or cubed is negative, right? But if you square a negative, you get a positive. If you cube a negative, you get a negative, right? And then this is going to be negative. So it's a positive and a negative, which gives you a positive. And it's going to get huge really fast. It's going to be like so. The book talks about the leading term, which would be the second power of x, third power of x, and x, sixth power of x, which also acts like this. So you can use either method. I prefer you think about what happens. Positive or huge negative number, because that's easier to remember than a rule that you don't understand. Okay, but that's up to you. Okay, now at this point, the degree is 3. This means that at this point, this acts like the graph of x cubed does at the origin. What does x cubed do at the origin? Well, it comes up, it levels off, it goes on, right? Now, it's a multiple of x cubed, which means it could be a negative multiple of x cubed, which means it come down and level off and go down, right? But it acts like x cubed here in that sense. So it's going to come down here. It's going to level off before it goes back down, and then it's going to go back down very rapidly. So it's going to do this here. At 5, 0, x squared, so it's going to act like x squared. What's the graph of x squared look like? It's a parabola with the vertex at the origin. It's going to act like a parabola with the vertex at this point. So we're going to have to level up, we're going to have to come down here, and then we're going to have to come back up here, we're going to have to turn around, and then we get to go up through this. So we'll get them to do something like this. But it's got to act like an x cubed here. It didn't level off quite enough. I should have leveled it off even more. I'll turn around here. I kind of missed the point. You get the idea. And then this is like a linear function. It's going to go through temporary, in the close neighborhood of this point, it's going to be a straight line, close to a straight line. Just like this is going to be close to a parabola at 5, 0. Going to get a little further away, and this is going to be close to a negative multiple of x cubed. Okay? And that's pretty much it. So it's not particularly difficult to graph polynomial functions. Okay. So that's plenty.